Hello class, this is a video tutorial on the integration involving inverse trigonometry. By considering the derivatives of inverse trigonometry, as we've learned in prior lessons. So these are all the derivatives of inverse trigonometry. By simply reversing these, we can learn the integrals involving inverse trig functions. So if we know that this is the derivative, simply reversing the process, we can see that the integral of this will give us inverse sine of x plus c. Likewise, it's the same procedure for all of these. You can see that these are the integrals, but only these two are found on the HSC reference sheet. Okay, you can simply adapt this for inverse cosine by having the negative in front here. All right, so let's get straight to it, and let's give these three examples a go. At any time, you can pause this and give it a go yourself, but I'm going to start with number one right about now. Okay, so for this, if you can see that it is actually one of these three, but if you can integrate it straight away, that's excellent. But it's best to break this down into something that looks more akin to these. So a squared. So if I were to change this a little bit, I would write it as 0, 3 to 2. So far, everything's the same. But instead of 9, I'm going to be writing it as 3 squared dx. Because now this is of the exact same form as this one. So our integral of this is going to be the inverse of sine of x on 3, but I like writing it as 1/3 of x, from 0 to 3 on 2. Substituting 3 on 2, we get sine inverse of 1/3 times 3 on 2, which cancels out like so, minus sine inverse of 0. This right here is sine inverse of half. So into our calculator, sine inverse of half gives us pi on 6, or 30 degrees, minus sine inverse of 0 is 0. Which we can just conclude that the integral, the definite integral of this one is just pi on 6. Okay, so I hope that, that wasn't too difficult. You can pause and try the next questions yourselves. I'm going to give myself a little bit more space here. And let's begin. For this one, I hope you can see that it's actually more closely related to this one here. It's a little tricky, but I hope I'll take you through how we might get there. So here we go. First, I write everything so that it looks like one of these functions here. By that I mean I write it in index form, like so. Oops. 1. 4 is 2 squared. And 9x squared, I'm going to write as 3x all squared. But now take a look. This is really close to this one here. It's got a squared plus the function of x squared. All that's missing is the derivative on the numerator. Now, we can actually make it so that there is a 3 on top like so. But if I multiply by 3, I need to divide by 3 straight away. So this is the same as 1/3 2 squared plus 3x squared with the 3 in the numerator. Notice how these two would cancel to give us 1. So it's still the same equation, or the same integral. Now that we have this, this is exactly what we need to get the inverse of tan. So using that integral, keeping the 1/3 here, so we get 1/3 times 1 on a, as shown there. So a is 2 here. Inverse tan of the function of x over a. So this can be written as 3x on 2. And since this is an indefinite integral, we can actually stop at the next step, where it is going to be 1/6 tan inverse of 3x on 2 plus c. And that right there is our integral. We have one more function, or one more integral to evaluate. Once again, you can pause the video and give it a go yourself. Let's answer it right about now. So first, we actually need the derivative of u. So we write this as du on dx equals x cubed. Oops, sorry. 3x squared. Rearranging this, we get 1 on 3x squared du equals dx. Using this substitution, we get the following. Our integral is equal to x squared remains where it is. You notice how x to the power of 6 is actually x cubed squared, but x cubed is u. So we write this as u squared. Dx is now going to become this substitution. It's going to be times 1 on 3x squared du. Now from here, the x squares cancel out, which leaves us, so let's cancel these, which leaves us with this 1/3 hanging out in the outside here. So 1/3, the integral of 1 over 1 minus u squared, all square root du. Now this function looks just like this basic one here. So this will give us 1/3 sine inverse of u, which when we resubstitute back the value of u, we get 1/3 sine inverse of x cubed plus c, and that there is our answer. So I hope that gave you an insight into integration involving the inverse trigonometric functions. Hope to see you in the next video, and best of luck.